2, which is on relations and functions. And so first of all, we need to define what a function is. Okay, a function is a relation in which each element of the domain is paired with exactly one element of the range. Okay, each element of the domain is paired with exactly one element of the range. And so there are two ways we can classify functions. We can classify them as one-to-one, or we can classify them as onto. Okay? A one-to-one function means that each element of your domain is paired with exactly one unique element of the range. Okay? Each element of the domain pairs to exactly one unique element of the range. An onto function, on the other hand, is kind of like the flip. Okay? It says that each element of the range corresponds to an element of the domain. So if you look at those two illustrations, you can see an example of a function that is one-to-one but not onto. And why is this first one here not onto? Because C doesn't have a partner. Okay, and so that's why that function is one-to-one, because each element of the domain is paired with one of the range. And the second one, okay, if you know, look at the second one, why is the second one not one-to-one?
Because C has two.
Because C has two, yep. Okay, so notice 3 and 4 both go to C, so that's why that one would not be onto. Now, a function can be both. It can be both one-to-one and onto. And notice what that one looks like. Okay, each element of the domain is paired with exactly one element of the range, and it's one unique element of the range. Okay, and each element of the range is paired with one element in the domain. So what we're going to do is we're going to classify functions as one-to-one and onto. So first of all, it says state the domain and the range of each relation. Then determine whether each relation is a function. If it is a function, determine if it is one-to-one, onto, both, or neither. Okay. So, let's go ahead and list our domain. What is our domain going to be here? Mm-hmm. Okay. Good. So basically, if you remember, the domain is nothing more than the first values, the x values. Okay. The range. What's the range going to be here? Okay. So what I'm just going to do quick is I'm just going to make myself a visual. So you have -6, -5, -3, -1, 6. And then I have -1, -9, -7, 7, and I've already got a -9 written. So -6 goes to 1, -5 goes to -9, -3 goes to -7, -1 goes to 7, and 6 goes to -9. So is that function one-to-one? Why not one-to-one? Because -9's got 2. Is that function onto?
Yes.
Yes. Okay. And once it is onto, you don't have to worry about the last two. It can't be both, and it can't be neither. So it might help to draw the visual. Okay. State the domain and the range of each relation. Okay. Then determine whether each relation is a function. If it's a function, determine if it's one-to-one, onto, both, or neither. So let's start with the domain. What's the domain going to be? 2. Okay, so I've already got the -1 and the 2, so I don't need to list them twice. Okay, let's look at the range. What do we have for the range? -2, -1. Okay. So now let's go ahead and draw that out and see what we have. We have 2, -1, -2. And then over here I'm going to have -2, -1, 0, 1, 2. So 2 goes to -2, -1 goes to -1, -2 goes to 0, -1 goes to 1, and 2 goes to 2. Okay, now, first of all, is this a function? Why is it not a function? Yep. This is not a function because of this number and this number. And the reason why it's not a function is because notice you have 2 arrows coming from both of those. Okay? Now, if you're curious, you're like, well, what do you mean? Let's say, for example, I just wanted to plot those points real quick. Okay, so 2, -2 would put me down here. Okay, -1, -1 would put me right here. -2, 0 would put me right here. -1, 1 would put me right here. And 2, 2 would put me up here. Now, a function has to pass what's known as the vertical line test. Okay? Would this pass the vertical line test right here? No, it doesn't. It touches 2 points. Would it pass the vertical line test here? No, it touches 2 points. Okay? So that's another way you can do it. Graph it out real quick. See if it touches 2 points. Okay? So since that's not a function, you would just write not a function. So let's go ahead and look at this one. State the domain and the range. You've already got the domain. What's the domain going to be? Yep. Now you still have to list it, even though it is labeled. It should be fairly easy to write out the numbers. Okay, the range is 0, 2, 4, 6, 8. So is this a function, yes or no? Yeah. Okay. Now we have to determine if it's 1-to-1, onto, or both. So is it 1-to-1?
Yes. No.
Why is it not 1-to-1? Okay. Because the -1 and the 1 both go to 6. That's why it is not 1-to-1. Okay, it's not a unique element of the range. Is it an onto function? Why is it not onto? 8 doesn't have a buddy. So obviously, then what's this one got to be? It's got to be neither. So it is not 1-to-1 because why? Let's go over that again. Why is it not 1-to-1? -1 and 1 both go to 6. That's right. It is not a unique element of the range of those two. Why is it not onto? Because 8 is not paired, because remember, to be onto, each element of the range has to be paired with an element of the domain. Okay, so therefore it's got to be neither. So those are kind of the checks you need to go through. All right, so we're going to just talk real quick about this. I don't know necessarily if you need to write this down because it should make sense. When you think of the word continuous, and we're going to look at the continuous one first. When you think of the word continuous, what does that mean? It just continues and never stops. So when I think of a continuous graph, I think of a line. A continuous graph means that if you were to walk along that line, you're never going to fall. Okay, so if I keep walking along this line, I'm going to keep walking and walking and walking, I'm not going to fall. A discrete function, on the other hand, is one that has a bunch of segmented points. Okay, so a discrete means a bunch of segmented points. Continuous means it just goes on. It consists of a line or a smooth curve. Okay. Oops, let's go back and look. Okay, vertical line test. We briefly discussed that a few slides ago. Let's go ahead and look at this first slide, or this first graph. Is that one a function, yes or no? Okay. I got some hesitation, so let's go through what we do with the horizontal, our vertical line test. With the vertical line test, I take a vertical line, like your pencil, and I move it along the graph. If at any point it touches more than 1 point on the graph, it is not a function. So as I move this orange line along, does it ever touch more than 1? No, so this is a function. Okay? Let's look at the next one. Okay, I'm going to move this along. At any point, does it touch more than 1? Yes, where? Right there. Yeah, it touches 2. So this is not a function. Let's look at the last one. Oh, what's the last? Wrong one. There we go. Is this one a function?
Yes.
Yes.
Yes. No, it doesn't. Because the one is open circle.
How many think it is a function? Raise your hand. It is a function. Raise your hand. See, 3. How many think it is not? So let's try it again. How many think it is? Not. The is have it. It is a function. This is why. Here, when you think it touches 2 points, it actually doesn't, because the one circle is open. So remember that open circle means you don't include it. So that is why this one technically passes the vertical line test, and this one is a function. All right, we have a few things last to look at. Okay, the graph shows the length of the Tour de France in kilometers each year from 2000 to 2009. Is the relation discrete or continuous? Does the graph represent a function? So first of all, is that graph discrete or continuous? Discrete. Consists of points. Does it pass the vertical line test?
Yes.
Yes. There you go. That's it. It's identifying things on the graph. That's all you have to do. Okay, it says graph y equals 1/2 x minus 3. Determine the domain and range. Then determine whether each equation is a function. 1-to-1, onto, both or neither. State whether it's discrete or continuous. Okay. Ideas where I should start with this one.
Solve the
Let's go to our old standby. X, Y.
1, 2, 3, 4.
Okay. You know what? I actually, let's do 0, 1, 2. At 0, what do you get? So I'm plugging 0 in right up here, folks.
Oh, okay.
What do I get?
negative 3.
-3. If I plug in 1 up there, what do I get? -2.5. If I plug in 2, what do I get? -2. So now let's plot those. 0, -3. 1, -2.5. 2, -2. So if I look at the graph, okay, what's my domain going to be? Domain is your x's, right? 0, 1, and 2, yeah, but could it be 3?
Yeah.
Could it be 4?
Yeah.
Could it be 5? Could it be 100? So it could be really what? Anything. So you know what? This is how you answer that when it's anything. All reals. Okay, it can be any value, and you'll still get a y value. What about the range? What can you tell me about the range? The range is up and down. What do you know about the range? It could also be anything, because the arrows keep going. So how would I answer if it could be anything? All reals. Yep. Now this is just a little tidbit. If you have a line like this, you're going to have all reals for both domain and range. It's just a given. So now let's figure out, is this 1-to-1, onto, or neither? Both or neither. So first of all, is this 1-to-1?
Yes.
Yes. Is it onto?
Yes.
Yes. Is it, so obviously then what would my answer be? Both. And then last but not least, discrete or continuous? Continuous. Okay. So going through those, you have to plot them. Once you plot the points, identify domain, range, and then 1-to-1, onto, both or neither, and then discrete or continuous. Okay, so let's look at this one. Y equals x squared plus 1. Now this one I'm actually going to change things up a little bit. I know on that previous one we did 0, 1, and 2, but anytime you have like an x squared or something that's just not x, you need to do a negative number as well. So we're going to do -1, 0, and +1. So if I plug -1 in here and I square it, what do I get? 1. Then you add 1, you get 2. Let's plug in 0. Square it. What do you get? Plus 1. Okay. 1. Square it. Add 1. 2. Oh, okay. So I go to negative 1, 2, 0, 1, 1, 2. What do you think this graph is actually going to look like? What would you do? Yeah. How about a smile? Okay. So what's the domain going to be, folks? What? What's the domain? The domain is x's. Left to right.
That's gonna be
Yep, anything, all reals. Now the range, on the other hand, is that going to be anything?
it's gonna be greater than 1.
Okay, so y has to be greater than, could it be 1? So greater than or equal to 1. So then now let's look at this. We have to determine, is it a function? So does it pass the vertical line test? Yeah. So is it 1 to 1?
No.
Why is it not 1 to 1?
Because it's 2.
That's right, because you have 1 and negative 1 both going to 2. So it's not 1 to 1. Is it on 2? Yes. Okay, so obviously then it's on 2, so I can stop. Discrete or continuous?
How do you determine that?
Discrete will just be a bunch of dots. Continuous is just going to be a curve, okay, or a line. So this is continuous. So those are kind of the check mark steps you're going to have to go through. The very last problems we're going to look at, okay, is we're going to be going ahead and evaluating functions. Okay, first of all, independent, dependent. I don't know if you necessarily need to write this down. This is just something you should already know. We talked about it in Algebra 1. Independent just basically means that that variable is independent of the other one. The dependent variable means that what happens is its value, okay, its value affects another one. And so that's what it says. The value is dependent on the value of the independent variable. So real quick, function notation. Once again, this is review. F of x equals 5x plus 4. This is what a function looks like. It's written in this form. Remember, f of x is nothing more than y. So those two are interchangeable. So it says, given f of x equals 2x squared minus 8, find each value. So what am I going to do if I want to find f of 6? Put 6 in for x. Order of operations states you do what first? The 6 squared. So this is what I'm going to do first. What is 6 squared? So I really have 2 times 36 minus 8. What is 2 times 36? Minus 8? 64. Okay. So all you're doing is plugging those in and going from there. Let's look at the next one. 2 times 2y. Now notice whenever you have a quantity, it's usually good to put it in parentheses, kind of like I did right there. So what am I going to do first? Square the 2 and square the y. So I end up having 2 times. Okay. What is 2 times 4y squared? Minus. There you go. That's it. You leave it in terms of y. Okay, I think we have a few more to look at real quick. Yep, there we go. So g of 2.8. So tell me what I'm going to write. Okay. Now you have to do all of that, okay? So let's start. Very first thing you're going to do. The 2.8 squared, and what do you get? What do you get? 7.84? Okay, minus, what's 5 times 2.8? 14 plus 3.5. So now what I need you to do, what is 0.5 times 7.84? 3.92 minus 14? Plus 3.5. 6 point what?
6.58.
Okay, there you go, negative 6.58. And last but not least, G of 4a. What you're going to do is do the exact same thing. You're going to plug it in. So I've got 0.5 times 4a, oops, quantity squared, minus 5 times 4a. I'm having trouble with the pen for some reason. And then plus 3.5. Whoa. Okay, so let's go ahead and start with the 4 squared. What do you get there? 16a squared. What's 16 times 0.5? 8. So really here I get 8a squared. Okay, what do you get 5 times 4a? What do you get there? 20a, and then plus 3.5. So that's going to be your answer there. Okay, so what you need to do for me then is going to be on page 65. I need you to do 11 through 32. Okay, page 65, 11 through 32.